Hello everyone, welcome to my channel and learn with Teach Alex. In today's lesson, we're going to be dealing more about factoring. In my previous video, we learned how to factor polynomials using their greatest common monomial factor. So let me just have a quick review of what we did last time, okay? We know that a polynomial can be factored as a product of a monomial times another polynomial. So how did we get this factor? First, we find their GCF, which is 8x, and then we divide this expression by 8x. That's how we obtain the second factor. So anyways, that is just a quick review. But now we're going to move to the next type of factoring, which is the difference of two squares. I'll show you some examples for you to have a better understanding about this lesson. Okay? These expressions are called the difference of two squares. And why do you think it was given such a name? As you can see, they consist of two terms, right? And each term is a square. Okay? That is 6 squared and 5 squared. A cube raised to the second power. Okay, so let me just adjust my... Alright, that's it. And the second term is always negative. Okay? So technically, that is why it's called the difference of two squares. Now, how are we going to factor these expressions? Let's try to answer them one after another. Okay? So let's factor them one by one. X plus 1 times x minus 1. And then sorry. 2x plus 6 times 2x minus 6. Or a cube minus 5 times 4a cubed plus 5. Okay? Now, take a look at how these expressions are factored, how each relates with each other. Do you see any pattern? You may notice that each expression is factored as a product of two binomials, right? And the factors are the sum and difference of the same term, right? Therefore, to factor any binomial of the form a squared minus b squared, that is the difference of two squares, we do these steps. Oh, let me just erase this first. So this is the procedure in factoring the difference of two squares. First, we need to obtain the square roots of both the first term and the second term. Okay? And then express these factors as the product of the sum and difference of these square roots. So, can you see the pattern now? Let's try to answer this one. 100x squared minus 36y squared. Okay. So first we need to obtain the square roots of both the first term and the second term. So square root of 100 is 10, and x squared is x. There's the first factor. And square root of 36 is 6. Y squared is y. And then next is to express these factors as a product of the sum and difference of these square roots. So 10x and 6y, x and 6y. So you can actually interchange the signs. It doesn't matter if whichever is positive or negative, it won't really affect the resulting product. Okay, so let's have another example. So first we need to get their square roots. Square root of x to the fourth power is x squared. And square root of 9 is 3. Y to the sixth power is y cubed. And to write their products, we need to write this as a product of the sum and difference of the square roots of the first term and the second term. So x squared and 3y cubed, x squared and 3y cubed. Okay, so therefore we conclude that the difference of two squares can be factored as the product of two binomials. Okay? All right. So this is the factored form. Okay. Factored form for each of the binomials. And take note that a certain variable, okay, are squares if its exponent are even integer. Notice that the exponents, all the exponents of the variables are all even, right? So they are squares. Expressions such as x cubed or y to the fifth power or z raised to 11th power, where the powers are not even, are not squares because we cannot get their exact square roots, right? So that means that not all expressions can be factored using the difference of two squares. You should know when to use them, when you can factor expressions using difference of two squares. So I'll give you one example for that. So first, we need to verify if this expression is a difference of two squares. And as I mentioned just a while ago, that a certain variable is a square if its exponent is an even integer. But here, the exponent of the variable y is not an even integer. So therefore, this is not a difference of two squares. And it cannot be factored as the product of the sum and difference of the same term. Okay, so how are we going to factor this expression? So we're going to go back to our first topic, which is the using the common monomial type of factoring. So we're going to find the GCF for this expression. And the common factor for 3 and 12 is 3, because 12 is multiples of 3, right? And then we have y as common to each of the term. So this is our GCF, or common monomial, greatest common monomial factor. And then we need to find the second factor, by dividing this expression by 3y. Okay, so we get y squared, oh no, sorry. So we get x squared, y squared, minus 12 divided by 3 is 4, and then y is cancelled. All right, so what do you notice about the second factor? Notice that the variables, the exponents are squares, and the constant is also has a square root of 2. So that means this is the difference of two squares. Okay? So since the second factor is a difference of two squares, therefore we can extract their square roots. So the square root of x squared y squared is xy, and square root of 4 is 2. All right? So to finally complete the factorization, to complete this factorization, we need to express one factor. Okay, so this is a complete factorization. 3y, then the product for this expression. Okay, so we need to express one factor, okay, this one, xy, as the sum, and the other one is the difference. All right. So now we've completed the factorization by expressing one factor as the sum and the other as the difference. Okay? Another example. 16x squared minus 9. First is verify the terms are squares. If so, then extract their square roots. Square root of 16 is 4, and then x square root of 9 is 3. Next is to complete the factorization by expressing one factor as the sum, okay, for x, sorry, okay, 3, and the other as the difference of the same term. So 16x squared minus 9 is equal to the product of two binomials. So that is how this expression is factored. Another example would be 3x squared minus 27. So first we need to verify if the expression is a different or if the terms are squares, okay? So since 27 is not a square because we cannot get their exact square roots, right? And also the number 3. So what we're going to do is we need to factor this expression using the greatest common monomial type of factoring. So we need to get their GCF, okay? So the GCF for this expression is 3 because 27 and 3 are divisible by 3, okay? Next is to divide the second factor, or I mean to get this, to obtain the second factor by dividing this whole expression by 3. So we get x squared minus 9. Next is to take a look if this expression is a difference of two squares. So it is, right? Because we can extract their square roots. Square root of 9 is 3. Okay, I have to write it legibly. Okay, 3. And then the square root of x squared is x. So therefore, and then complete the factorization by expressing one factor as the sum, of the square roots of each term, and the other is a difference. So this is the final answer, the factored form for this expression. And that's just about it for this lesson. We're going to continue on the next type of factoring, which is the perfect square trinomials, which will be covered in my next video. So see you around. Bye.